Hi, this is Mrs. Luce. We're going to get into the nitty gritty of atoms. So here's our introduction. We're going to start by discussing what is the structure of an atom. In other words, what's it made of? So an atom is made up of smaller particles. We call those subatomic particles. The three main subatomic particles are protons, neutrons, and electrons. And we're going to get into each one of those. Atoms have a center nucleus. So, right in the center is a circle sphere um, with electrons around it. The nucleus is in the core and it contains protons, they're positively charged, and neutrons. Now, neutrons can be a little tricky because people start thinking neutrons and they start wanting to go negative with them. Neutrons are actually neutral, they have no charge at all. Electrons are on the outside of the nucleus and they're moving around really fast outside of the nucleus, and they have a negative charge. Negative charge. Okay, so we could draw it something like this. In that nucleus, you've got protons and neutrons, and outside we have electrons. Okay, so if we were to look at a carbon atom, you can see in the nucleus there are 6 positively charged particles, they're protons. There are 6 neutrons, and notice there's no charge on them at all. And then on the outside of that nucleus, you've got 6 electrons, and they have a negative charge. So in an atom, the number of protons equals the number of electrons. That's important to remember. You might want to make sure to write that down. So let's look at the question here. What effect do the neutrons have on the in the nucleus on the atom's electrical charge? If you said they have no effect on the electrical charge, you would be correct because they are neutral. Okay. Over the years, there have been lots of different models of the atoms. There used to be a chocolate chip cookie one. An atom is like a chocolate chip cookie. You got the dough, and then you got little particles inside of it that are chocolate chips. Um, that's changed over time. So right now, currently, we use the electron cloud theory. So in this theory, it says that electrons move outside of the nucleus in a sphere, um, and they're like a cloud, that they could be anywhere in that cloud at any time because they're very fast moving. Well, the electrons that have lower energy, they're going to be closer to the nucleus. And if you think about it, the nucleus has the positive charge, right? It's got all those protons. The electrons are negative. So there's going to be a force of attraction there between the positively charged protons and the negatively charged electrons. And so they're held there tighter. They don't move as much. They don't have as much energy. Electrons that have higher energy are going to be the ones that are farther away from the nucleus. So the farther away they are from that positive charge, the more movement they can have. So they have more energy. Most of an atom's volume, remember volume, how much space it takes up, is where the electron cloud is that's where the electrons are at. So if we were to look at the masses, electrons make up most of the volume, that cloud area that's around the nucleus. It takes up most of the volume, but it does not make up much of its mass at all. So it's going to take 2,000 electrons just to equal the mass of 1 proton. Okay, they are very, very small comparatively in mass. So a proton and a neutron have about the same mass. They're measured in atomic mass units. One proton or one neutron have the mass of about 1 atomic mass unit. Electrons, on the other hand, have about the mass of 1/2000th atomic mass units. So it's going to take 2,000 electrons to equal the mass of one proton. And we could put this all on this nice table to review what we just learned, that the protons have a positive charge, a mass of 1, and a symbol of P. The neutrons have no charge, a relative mass of 1 atomic mass unit, and their symbol is N. Electrons have a negative charge. Its mass is 1/2000th of atomic mass unit, and its symbol is E. How are elements described in terms of their atoms? Well, elements are identified by one key thing, and that's the number of protons that it has. So hydrogen has 1 proton. Carbon, on the other hand, has 6 protons. So the whole number on the periodic table, which is called its atomic number, is going to tell you the number of protons. Okay, so the atomic number tells you the number of protons in the nucleus. Carbon has 6, oxygen has 8, and iron has 26. So you always look at the whole number, the atomic number, to find the number of protons. Isotopes. Okay. So what you have to understand is that every atom is determined what it is by the number of protons. So any atom you find with 26 protons, it's going to be iron atom. Okay, but they can have different numbers of neutrons. So carbon always has 6 protons. Carbon 12 actually has 6 protons and 6 neutrons. Carbon 13 has the 6 protons, but it's got 7 neutrons. Carbon 14 has 6 protons and 8 neutrons. So to be carbon, you have to have the 6 protons, but you can have different numbers of neutrons, which means you can be a heavier or a lighter version of that atom. So isotopes are identified by the mass number. The mass number is the number of protons plus the number of neutrons. Okay, so you add those together and that's your mass number. So that's just like, how many atomic mass units does it have? The most common isotope for carbon is carbon 12, but there are a couple other isotopes, carbon 13 and carbon 14. Even though they have different mass numbers, carbon atoms are all going to react the same way chemically. So it still acts like carbon, it's either a little heavier or a little lighter. In this case, they're all heavier. So carbon 14 isotope is used for like dating fossils and stuff, and it's got an important use in for archaeology and stuff. So why are models useful for understanding atoms? Atoms are very, very small. They're hard to study. We don't have any microscopes that are going to show us an atom. I mean, they're available, but they're scanning, tunneling microscopes. So usually we can get pictures occasionally, but that's about it. And so because of that, we need to make a model. We need to model what these look like to help us understand it. A tiny bit of dust contains 10,000 million billion atoms. A sheet of paper is about a million atoms thick. So I mean, it's almost mind-boggling trying to understand how small an actual atom is. So scientists use these models to help describe atoms. And remember that a model is a diagram or a mental picture or something to help explain a science concept. Okay, well, I hope that you have enjoyed this, and until next time, I hope you learned something. Take some good notes.